Hey everybody, this is Jim Grisanzio from the Oracle Groundbreakers team, back for some more interviews for the Oracle Groundbreakers India Yatra, which is taking place this week and next week, and of course last week as well. 3-week conference, and I'm here talking with as many speakers as I can get my hands on. There's too many for one person to do, but I got about 30 or so actually to talk to. And tonight I'm going to talk to Charlie Berger. Charlie is a senior director in product management, and he's into machine learning. And this is something that I'm really, really interested in. And so Charlie, welcome. Welcome to the program.
Thank you for having me.
So I understand you're on the East Coast of the U.S.
Yeah, I'm just outside of Boston.
Okay.
I work in the Burlington office location.
Okay.
Physically live in a town called Harvard, which is loosely associated with Harvard University. Used to have the summer campus out here, but I'm out in sort of the burbs, out on the outer belt, if you will, but basically Boston.
Cool. I used to live in Boston as well. And San Francisco, and then Tokyo, and now Osaka. So I have certainly have gotten around. So Charlie, this is the first time we're meeting, actually, which is really, really good. I'm specifically interested in meeting new people on this particular conference, and so maybe you can, for me and for everybody else, just give me a little bit of a summary of who you are, what you do at Oracle.
Okay, hi, I'm Charlie Berger. I'm the Senior Director of Product Management for the Machine Learning, AI, and Cognitive Analytics here at Oracle. Been here since '99 when Oracle acquired a company called Thinking Machines. Thinking Machines, I used to be the VP of Product Management and Marketing. It was a much smaller company, and we got acquired, and for the last 20 years, I guess we've been slow, development has been slowly stem selling algorithms deep inside the kernel of the Oracle database, and that's what we do.
So interesting choice of word, stem selling. You want to explain that a little bit? I mean,
I guess it's a good point. Thank you. The most people think in machine learning. I guess I go back to this original mantra that we've had when we got acquired, and it was this vision that as the volume, and this started, if you think of it going all the way back to '99, where you had larger amounts of data. They used to call machine learning data mining, and data mining discovery of nuggets in your data, in large amounts of data. And we said, well, the large amounts of data are going to get bigger and bigger and bigger and bigger, and at some point that mountain of data is going to be so gargantuan that you're going to say it makes no sense to move that mountain of data, to analyze it, to compute a mean or a median or run a neural network on it or whatever. Doesn't it make more sense to, what we say, move the algorithms to the data, rather than moving the data to the algorithm? So that's what we've done, and we've taught the database how to do higher level math. So when we say stem selling, you'd say, well, let's put a neural network in there. Well, neural networks are not so easily implemented inside of a 40-year-old relational database. So what did we do? We thought, well, are there any class or category of algorithms that would sort of lend themselves to an in-database implementation? And there are some. There's one called the naive Bayes algorithm. Another one's called the association rules a priori algorithm. And they're basically just built on counting principles. And Lord Bayes came up with this stuff back in the 1760s, I think, is when he published his papers. And it really just says, if I count the number of times the person is a male and buys a motorcycle versus is a female and buys a motorcycle, rents a house versus owns a house, has a dog versus a cat, is in age category low, medium, or high, or whatever, and on and on and on. It's called naive because you treat all those algorithms sort of independently, not as interaction terms. And you can use the database. That's just a complex query in the database to formulate that together and codify that as a model. And so, we stem cell those mathematical principles into the SQL kernel of the database. So all the functionality we do is peer to all the rest of the Oracle functionality. So under Andy Mendelsohn and Juan Loaiza's tribes, all the guys that when they do something like sort or rank or select, they make that faster, like even the smart scan queries in Exadata. When you do a smart scan query, we're so integrated and stem celled into the kernel of the database that after you've built a model, like you say, select all people who are males above the age of 40, and I predict they're going to default on a loan with probability greater than 70%. That last little prediction probability function actually also gets executed at the storage tier of Exadata smart scans. So it is not like, your father's Oldsmobile, to quote a very old phrase. It is not Python. It's not legacy or Python TensorFlow kind of architectures. It is the same kind of algorithmic techniques, but implemented in the construct of a very, very powerful and capable and HIPAA compliant and and auditing and backup and all the other kind of infrastructure that you need, architecture. So that's why, yeah, I guess I stem cell. Yeah.
Yeah, it just strikes me because I mean it's such a visceral term, and when I talk to AIML people, I get this strange sensation because a lot of these things they sound so new, but the work has been going on for a long time, and
It's a long time. Yeah.
yeah, and it's like the Oracle database has been around for not just a couple of months here, and so it seems that it's extremely intelligent now from this work.
Yeah, I mean, we've got over 30 algorithms inside the database, and what people, and we talk about this a lot, kind of what's going on in the industry, because there's always these, data scientists, very, very smart people, but they would never, ever expect a database to be able to do math. So they use what's out there. They use Python, they use R, TensorFlow, various different amazingly great, analytical platforms to do stuff. And when we say, well, the same algorithm exists inside your database, and it's as of December 5th, 2019, it's actually free. So you could use that. You could use SQL or R APIs, or Python APIs are coming out this summer, or a notebook or a drag and drop GUI. You can use whatever you want, constructs to kind of puppet string your way to have those algorithms do their math. And it's all inside the database. So if you're trying to do a logistic regression or a neural network or a support vector machine or whatever, why would you ever move the data somewhere else if you can do it inside the database? And then when that's a hard concept for most people to grasp. They're listening, but they just kind of, it's going over, they're like, I don't really believe this. It doesn't make any sense to me. But
Why?
then once they kind of grasp that, then you say, well, okay, moreover, those models are first-class objects. I could build it as a data scientist and give you only the permission to score with it, right? I could see who tampered with that model whenever, right? I could say, well, marital status is not single, married, divorced. It's a paragraph. It's a prenuptial agreement. It's a bunch of tweets. It's emails. And I can use Oracle text to tokenize, basically pre-process that data and bring us a vector of terms. And if you use certain words twice as often as everybody else uses in the corpus those terms, that's almost the equivalent of being, twice the salary or twice as tall. We've quantified or digitized unstructured data, and you can also use the transactional data. So all sort of 360-degree view of the customer that you want and that they store in the database. All we did was, not force you to flatten that out and move it out to Python or something to do the math. We just brought the algorithms to the data, because algorithms are small, data are big. That's what we do. And it just opens up a lot of possibilities.
I remember I was in India for Sangam, the conference for the Oracle, for the AIOUG in December. I remember Jenny announcing this, that it was free. And she had a long keynote with announcement after announcement after announcement after announcement. I actually had to get Sandesh with me and say, okay, you got to explain this, because she just announced a pile of stuff, and it seemed very, very significant. And this is what you're talking about now, in the sense of many people don't necessarily know that this capability is right there, for them.
That's why we do the hands-on labs, things like that. Yeah. That's why, as I said earlier off screen or whatever, I'm a co-founder along with this other clever guy, Sham Nath, and a bunch of other clever, hardworking people. They're all volunteers over the past few years, but we have our own sort of user group meeting that the India user group said, hey, they'd be kind enough to, put a link or whatever on their site back to ours or something, because we're all just out there doing the same sort of, cause, trying to help people realize all the cool things they can do. And we've, for the last 15 years or so, we've just been trying to, show the art of the possible, novel and interesting use cases. And, the database, Juan Loaiza has this really nice pitch. I mean, I've co-presented with Jenny once or twice, and at that conference, actually, I co-presented with her. And it's like that big elephant story, like the 6 blind or 7 blind men on the elephant. I only try to understand my little piece of the machine learning stuff, but what makes it the collection of everything so powerful is, the combination of all those things, the converged database. If some of your data is JSON data types, if some of your data is unstructured data, if you want to use REST API services, if you want to use and there's just so many, capabilities now that are all sort of intermingled into this very powerful database. You start to, to go a little science fiction on you for a minute. Can I do that?
Yeah.
Okay.
Yeah,
so I read way too much science fiction, and you watch things like Cambridge Analytica, what they did for the election predictions in the United States, things like that, and I go, yeah, that makes a lot of sense. And I don't know if they used our product or not. To the best of my knowledge, no. But There's a great book called The Naked Future by Patrick Tucker, and it says what happens in a world that anticipates your every move. And you sit there and go, what's he talking about? And he basically says everyone leaves all this digital exhaust. Everything you do has been recorded. Whatever.
Right.
There's a lot of good books and articles and things out there. And then he hypothesizes or proposes a very near future that he's talking about weeks or months, not years, in which for every variable, everything that you have, like my alive or dead, my marital status, my number of children, the blue book value of my car, the amount in my checking account, my savings account balance, everything that's likely to default on a loan. For every variable that I manage to curate and save and store in the database, there's a bunch of other variables that are related to that, and that I could theoretically almost automatically just use those other variables to build another prediction, store that prediction and the probability of that prediction all in the database. So if I have 500 variables, I really could have 1,500 variables, right? 500
Right.
variables of actual, another 500 of the prediction,
Right.
and another of the probability in those predictions. And I could have another variable say the reasons why I make those predictions. And now you can imagine querying your database for saying, show me all the people that are my top customers, of like the biggest savers in my bank, and then sort them on how much money I think they really should have. Like maybe they're storing the money in the Cayman Islands. And then I sort them on the difference, and I pull those people in and have a conversation. I mean, now I'm not only looking in a rearview mirror, I'm using all the data and I'm putting it to work, harvesting much more information and insights and predictions. And I think that's the future. That's what makes this all exciting. I hope a lot of people come to the HandsOn Labs and take advantage of that.
It sounds like it's now, not necessarily the future.
Yeah, I think it is. All it takes is just sort of rolling up your sleeves and get your hands on keyboard or whatever, and you can do a lot.
So, okay, so you're the first speaker here at this conference that I'm actually speaking to is actually going to run a HandsOn Lab. So let me ask you a question. How do you run a HandsOn Lab in a virtual environment?
It's both easy and hard, right? It's easy in the sense that I have materials that we've put together, and then if you go, what we're going to do is the autonomous database, which makes things so easy. I joke about this, but when they announced the always free tier at Oracle Open World, I was in Moscone West, and from the escalator on the floor of Moscone West up 2 escalators up to the 3rd floor where I was doing a HandsOn Lab or whatever, I opened up an account and set it all up, just riding the escalator. So it's that easy. Even I, not a DBA, set up my own account and set it all up and was ready to go. And so there are.
They are long escalators, though. They are long escalators.
They are long and slow moving, but it impressed me. And then so there's 9 example notebooks that are really straightforward. I created them. I've had some help to update a few of them, but they're pretty straightforward because I created them. They're not really complicated kind of stuff. And I can simply ask the customer, the student in the class, which is part of what we'll do, is there's these example notebooks. Export them out of the read-only file, import them into your own little instance. Oh, by the way, you need to be efficient, go out and ride your escalator up and set up the account just like I did. And that's the homework that they're supposed to come to the class with. If they didn't, they could set it up in the course of like 5 minutes anyway, right? And then go do what I'm instructing you to do. And I just kind of say, see what we're doing, click, see what we're doing. Imagine seeing a script with some graphs that come through it, and I kind of explain what they're doing. And we'll go through that for anomaly detection, for classification, for market basket analysis. We'll do a little script. There's a little paragraph in there for how to do a recommendation engine. And they are all the little pieces of things. They're also point to some other examples out in GitHub and various places where they can access that. And then if they, I'm trying to learn how to play guitar, and I have a video interview kind of thing like this with my instructor, and when I'm done, I'm supposed to go off and do some homework, like learn how to do this chord, learn how to do that chord. If I don't practice or do it, then shame on me. But if I do, then, and in the HandsOn Lab, we'll do as much as we can, but the idea is they can also go off and do more. Then they'll become what I call, an Oracle data scientist. And I say Oracle data scientist because they're using the Oracle technology and the database and all those constructs and privileges and security and backups and all the capabilities that they know so well in the database. And they're just simply adding some additional machine learning skills to their toolkit.
What sort of background are the people that you're expecting to be there?
It's a lot.
What are the requirements for basically participating in this?
Yeah, there's no requirements. I mean, the software itself is free. It's included if you have the Oracle database. There's always this always free tier, so you could be a student or anybody, to use the stuff. And we hope everyone shows up and comes. But in terms of skill set, like how many people could I don't know, learn to ski or learn to be a machine learning, kind of person. I think there's way too much to do made about, you have to have a PhD in machine learning, or you have to, write your own algorithms. If someone tells you to write your own algorithms, that's run away. You're not, someone else has already written the algorithm. You're just using that algorithmic technique to walk over the data you've set up, solve a data-driven problem. And really the hard part, and I've got this whole blog series that I have that kind of walks through this whole thing. It's like a 7-part blog series that says, from the evolution of the DBA from Oracle data professional to Oracle data scientist in 6 weeks. And so what I say is, you already know your data. You already know your business. If you work at a shoe company, you're probably worried about either manufacturing or selling shoes. So if you want to find people that buy lots and lots of shoes, and you want to do a predictive model, which would be maybe a use case you might want to do, you got to say, well, what's the business problem? I want to sell more shoes. I want to sell more coffee. I want to find people that default on a loan. I want to find people that recidivate, and commit another crime, and whatever it may be. So your business problem. You have to be very explicit in that. Then you have to kind of go back upstream and say, what's the data I would really want to have? Not the data that they tell me I have. What's the data I would want to have for that? So if I want to know, I know this one example, short story, trying to predict who's going to not show up for a doctor's appointment. Is it the weather up in New England, up in Vermont, New Hampshire, that kind of place? Is it and I'm the guy, a data scientist friend of mine, is asking me this at night when I'm trying to watch the game and drink a beer, and he keeps on texting me, what do you think it was? What do you think it was? And I go, I don't know, weather? Was it distance from the appointment? Was it snow? I have no idea. The answer was, were they ever a previous no-show? They ever canceled an appointment before? Or did any other family member ever be a no-show?
Really?
And so if you're and my wife, who's a nurse, says, of course, that's, everyone knows that. Well, that's the data with your domain knowledge you want to go get your hands on, right? You don't want to say, well, the DBA spit out all this data about their age and their address. I don't care about that. I want to know, can you tell me, were they ever a no-show before? Can you tell me what kind of procedures they were going through? Can you tell me whether or not they speak English as a foreign, do they need a translator? Is that what they're worried about? Do they have transportation? Think about the variables you need. And so formulate your business problem, think about the variables you need, get that data together. At that, there's a certain sort of now push it through a model. But I always say you don't have to write the algorithm. You just have to be sort of analytically curious. And my litmus test is, do you know the difference between a mean and a median? And if they give you a blank stare, move on. They're probably not. Maybe we could train them, but if they really look at that and go, geez, I don't know, that's a tough question, then they're probably not analytically curious, right? But if they do, if they know that, then voila, they can be a Oracle data scientist in 6 weeks of just kind of doing their homework and following along the notebooks, and off they go.
Wow. See, that just sounds to me like such an opportunity. I think so. Just, yeah. I want to read your blog series. Send me a link of that, actually, because, I listen to you guys when I do these interviews and stuff because, you have, specific expertise and stuff. But I'm also listening for me personally and says, what should I be involved with? What should I get involved with, for the future? Because the world is changing so quickly and continues to change. I got into technology 20 years ago specifically because it's an easy field to get involved with because it changes so quickly. It always is turning over, so you can always retool yourself, right? And so that's why I jumped in. And it's a little exhausting, to be honest, because it is always changing. But it always exactly. But on the other hand, it's providing opportunity all the time. You just listening to you and from speaking to you a little bit earlier, you sound very much like hands-on product manager. Not all of them are, and so you just described, a whole bunch of community work that you've done in terms of starting user groups and doing things like that. Talk about the value of that you get out of doing hands-on labs and working with people in a very, very direct way.
I'm from Missouri, you know where that is, right? The show me state, and it's like, don't tell me about it, show it to me, prove it to me that you can do it. And I was kind of raised in such a way, and early on in my career, it was like, constantly ask questions, try to learn something. If you sit down next to somebody at the lunch table, hey, who are you? What do you do? How do you do the accounting? What's the important stuff over there? And try to try to learn. And the thing about the machine learning that's really kind of a lot of fun is, I mean, just earlier today, I was on 2 customer calls I got kind of pulled into. One was trying to predict, medical kind of stuff, like almost doctor no-shows, but it's a different kind of thing. And the other one's guys from the government doing stuff that I don't know what they're doing, but it's complex, secret kind of stuff. And everywhere you go, you learn something new and different. And I just find it, you're trying to boil this ocean in some ways over the next 5 or 10 years, just to analyze all this data so we can have, predictions on everything. And it's complicated and it's interesting. And you're always, finding a cure for cancer, trying to find a cure for COVID-19, all these different kind of things. There is math and there are predictive models involved with all these different things. Like I used to run the life sciences vertical years ago, and there was this Pablo Tamayo, one of the smartest guys I know. He said, "Hey Charlie, there's this NCI 60 data set, 12 different types of cancer on about 112 different cancer patients. So that sounds like a small amount of data. But for each patient, they had 16,000 gene expression values, because there's like 20,000 genes in the human body. So you got like at least 16,000 records, and you're trying to see if I can build a predictive model to see whether or not you have brain cancer, breast cancer, renal cancer, or whatever." And you'd say, "Wow, can you do that?" Well, yes, you can. And we were building models with 82% accuracy inside the Oracle database. And so you sit there and you go, "Wow, I didn't know you could do that. Maybe I can combine that with something else about something else and build these very clever, interesting combinatorial models." I mean, there's no end to it. There's always something different, and you'll learn a lot from different cases. Can I one quick story that I learned that
Yeah.
Okay. So one of the ones I always like a lot was I was working with some guys from you learn sort of analytical tricks, if you will, right? I was working with some guys that were a spin-off of, I think it was Intuit or Quicken or someone that they're trying to form their own little tax company and analysis thing. They're trying to see how they could do as much of the math as possible inside the Oracle database, because they also knew and loved the Oracle database, which was great. And I said, "Well, how do you find tax fraud? What are you doing?" Because we had certain government agencies using our product before. I knew certain things. And they said, "Well, one of the things that is very key for us that we've detected is if I submit my taxes from an IP address as Charlie Berger, and then you submit an address from an IP address as Jim, then what I can do is I can run the Oracle count distinct over the data. And if my address has also been submitted 14,000 previous times, that just kind of is a little bit of a raising an eyebrow, like, what's going on? 14,000 other people have submitted a tax from that unique identifier address. Maybe not. Maybe he lives in an apartment building, who knows what. But little tricks like that, you kind of go, "I like that. I can take that to another use case." I know a woman that does a lot of money laundering kind of fraud, and she tutored under some woman that was like really good at it at a major bank. And you just pick up, it's like mentoring. You pick up skills from different people, different tricks. It's kind of exciting, I think.
That's really good advice. Really, really good advice. And these people, and just actually listening to you speak, it's also the ability to focus. It's ability to focus and look at the data and see where it actually takes you. But I mean, it is so fascinating to hear how intelligent that these machines are at this point.
Well, it's the database. I mean, it's not even just a machine. It's just your local Oracle database. Read down to the M's for machine learning in the documentation. You'll see it all. Or A for algorithms.
Cool. All right, Charlie, thank you very much for coming by. Greatly appreciate it. I'm really glad that you're presenting here.
Thank you.
And when is your session? When is it scheduled?
I believe it's today's Wednesday. I think it's on Friday. And I think it's at 10 o'clock in the morning Eastern time. I didn't quite realize. I thought they were going to schedule them in such a way that it wasn't such odd hours for people on the other side of the planet, but I believe that's what it is. Yeah.
Yep, that's what they got.
My apologies to anybody that shows up. You have my sympathy.
Yeah, they go up until late, actually. So, cool. All right, Charlie, thanks a lot. Hopefully I'll get to meet you live someday, and we can continue the discussions then. Thanks a lot.
All right, thank you, and stay safe. Take care.
Thanks. Bye-bye.